So initially it is in x-axis, and here we have y-axis. So consider the boat is touching it. One end of the boat is touching in the water at 0, and we can deal this problem with center of mass, with equations of center of mass. That means if this man is moving from one end to the other end, of course has to keep its center of mass in uniform motion, either in uniform motion or stable. So the total center of mass of the system is, the boat will do, if man is moving in walking in negative x-axis, the boat will move in positive x-axis to keep the center of mass of the system in the same place. Okay. Right. First, let us look at the center of mass of the system separately. So, if this is the center point, the center of mass of just boat alone is L by 2. Yeah, this is half the length of the boat. And the center of mass of the system will be little bit to the rightwards because the man has some weight. So let us put here is the center of mass of the whole system. The length is, let us call it as x t1. That is the length. That is the distance where the center of mass of the system is situated from origin. And length of the boat is, it is length is L. So this is the initial condition. So in this case, we need to find the point at which the center of mass of the system initially at, that is xt1. We have an equation to find it. We know that if we have multiple particles, the center of mass of the system can be defined as summation of I equal to 1 to n mass times the position vector of the system divided by the total mass of the system. So here we have two particles, right? So xt1, two particles, that is boat and the man. So xt1 is equal to sigma mixi is equal to sigma I equal to 1 to 2. We have two particles, 1 to 2 mixi divided by sigma I equal to 1 to 2 mi. So that is the equations that we will be using here. So by solving it, we will get xt1 is equal to m L by 2, capital M L by 2 plus small m. Here it is, let us call this distance as x. Sorry, ml by 2 ml. The distance is L divided by m plus m. That is the center of mass, the position of center of mass of the whole system. So let us write it here. So we have the initially the position of center of mass of the system we have here. That is xt1 is xt1 is equal to m xt1 is equal to m L by 2 plus ml divided by m plus n. That is the position of center of mass in the first case. Let us write this as equation number 1. Now we need to find what will happen if a man is moving from one end to the other end. So when the man moves from one end to the other end, what happens is the boat moves, right? So the situation is, let us delete this, change the image. Okay, the axis is the same, x-axis, and the boat moves by a distance. Okay, now the man is at this end of the boat. Okay, and let's consider this as the distance x which is moved by h is the distance which the boat has moved forward, and the center of mass of the boat is here. We know that this distance is x plus L by 2. Okay, and center of mass of the whole system is this. Let us call it as tx2. X t2. So this is the center of mass of the whole system, and here is the center of mass of the boat. Okay, we know that if we are looking from outside the boat, if from an external point of view, the center of mass xt2 stays the same as initial, and only boat moves forward. So in that case, we can find the new center of mass xt2, like in the previous case. Xt2 is equal to sigma equal to 1 to n m I, in this case xi prime divided by sigma I equal to 1 to n m plus m. And we know that in our case the new distances is the man is at here mx, so small m is the mass of man, and x the distance at which he is staying, plus the position of center of mass of the boat is mass of the boat times x plus L by 2, right? X plus L by 2 divided by m plus m, or we can write it as xt2 is equal to mx mx plus m x plus L by 2 by m plus m. Now as I told you before, we know that xt2 is equal to xt1, so we can just raise this image. We can equate it. We can equate xt2 is equal to xt1. So xt1 is equal to xt2, that is m L divided by 2 plus capital, this is capital M, L divided by 2 plus small m L divided by m plus m is equal to small m x plus capital M x plus capital M L by 2 divided by m plus m. And we can cancel this m plus n and m plus m. And we have here in the left side m L by 2, capital M L by 2, and right side capital M L by 2. So small m times L is equal to x into small m plus capital M. We need to find the distance moved by the boat. Small x is equal to m divided by m plus m times L, length of the boat. That is the answer. So if we substitute the values for small m and capital M and L, we will get the answer. So what is the uh, mass of the man? So x is equal to mass of the man is 70 kilogram times length of the boat. Length of the boat is 2.5 meters. 2.5 divided by 70 plus 100. So x is equal to 1.03 meters. So the distance moved by the boat when the man walks from one end to the other end is approximately 1.03 meters. So we have done our